All right, awesome. So thank you all for joining today's webinar. Um, Today's just going to be a quick introduction to IBA's latest software solution, myQA Proactive. Please note that the session is recorded, and if you have any questions at all, please put them in the chat and I'll answer them at the end of the webinar. Thanks. So risk management in healthcare can be broken down into three distinct areas. Proactive or prospective risk management is about brainstorming what could possibly go wrong and how we can prevent it from occurring. Typically, this is done prior to starting a new treatment technique, or perhaps if you have some new equipment. Retroactive or retrospective risk management is all about incident reporting and learning. So if something goes wrong, how do we prevent it from reoccurring? And finally, quality assurance, whether it be patient QA or your machine QA. So on screen is a flowchart of risk management in healthcare. Starting at the bottom left, we will initially start with a plan. We then analyze what could go wrong, how we can improve on as many areas as possible, and then we treat. Unfortunately, sometimes incidents do occur. These need to be reported and analyzed so we can ultimately improve the process and minimize the chance of such issues reoccurring. To break the chart down, along the bottom is your proactive risk management. The square's kind of in the middle, making the square, a weird expression, is your retroactive risk management, and your QA is down the bottom right. So as the name of the software suggests, today we're going to be focusing on proactive risk management. Later versions of myQA will incorporate incident reporting and QA results into the actual risk management software. But today it's just the proactive elements of it. So for proactive risk management, typically this is performed by a physicist leading a multidisciplinary team. This can be quite cumbersome and daunting to start from scratch, as there are a distinct lack of tools to help you make this process more efficient. There is a lot of value in risk management, and this often goes overlooked if the motivation behind it is simply compliance oriented, and that's where myQA Proactive comes in. And myQA Proactive has been designed to change your risk management from being a burden to being of actual value. You should be confident in the evaluation of your risks within your department so you can efficiently follow best practice and achieve higher level of patient safety by making educated decisions in your department. So before we jump into the software demo, it's worth highlighting that myQA Proactive includes a range of templates to give you a helping hand in starting effective risk management in your department. These templates have been prepared with IBA's clinical partners based off common practice and literature. So each template includes a typical description of the workflow, value modes, and safety measures, all of which can be customized to suit your needs. At launch, templates will include teletherapy, SGRT, with templates for things like MR-Linac and SBRT tomotherapy down the track. Okay, so I guess we'll just jump straight into the software demo. The software is installed locally, just on local hosts, and can be accessed via browser by basically anywhere in your department. I don't believe there's any restrictions on user logins as well. So when you open up myQA Proactive, you can, I guess, read with this intro screen. On the right-hand side, you have your list of different risk analysis. So if you were doing things like, if you had separate ones for something like the MR-Linac, it would come up as a separate list. Today we'll just focus on the teletherapy one. So this is, I guess, the screen you jump straight into. This is the process view for your FMEA, your failure modes and effects analysis. But I guess actually before we jump into that, first we'll have a quickly look at the settings, because it is worth noting that we put in your throughput of your department, so the amount of patients you're treating per year. We can also put in our currency. One of the cool things about this software is basically all your titles and everything is just basically from a text file, so you can actually go in there and change, edit any things that you like, you don't like. Um, so I guess to kick off, this is with a template, but if you're starting from scratch, we just hit edit, and we can add steps in your, I guess, treatment process pathway. We add the name of the step, so I guess we've got most of them on the left already, but if you're starting from scratch, you could chuck in, your CT sim, then put in the percentage of your patients that go through this step, and if this step is ever repeated. So I guess well, a better example might be treatment. So if you've got a couple of fractions, then you'd have a couple more repetitions for each patient. We can also add in substeps. So it's just the 3 dots here. Hit add substep. And this can be things, for example, in treatment, we've got a substep called preparation in the backgrounds or delivery. And that's just where we create substeps in here. Okay, so then we can add a new failure mode, just I guess so you can see what's happening. So your failure mode for treatment, it could be a range of different things, whether it's, we've got our wrong dose distributions from the mix-up of immobilization equipment. So I guess we're kind of building upwards in a way. So we can chuck in, I guess if you just did wrong, maybe I shouldn't type it all out. Wrong patient position. We can type in a cause. Maybe this cause is something like, you're a very busy department, you got a lot of time pressure, and it's just the patient hasn't been set up correctly. We can select the step or the substep that this is attributed to. And then the effect. So this is the things like if you set up your patient incorrectly, you can get a wrong dose distribution. So we can either create a new effect and just add anything alike. We can select from an existing effect. So if you've already got a couple already set in there, you don't have to, I guess, repeat yourself and keep adding it over and over. But I guess just as an example, we can, say wrong dose distribution. We then put in the occurrence, the severity, and detectability. So this is adapted from the AAPM TG100 report. And all it is you chuck in a number from 1 to 10 for each 3 of these based off this chart. So if it's got a high likelihood of occurring, you might put in a 9 for occurrence. But if it's not as severe of a problem, like a minor dosimetric error, you put in a 4 for severity and so forth with the chance you're going to miss it or detectability. Once you punch all these numbers in, we've got our severity up in our, I guess, main area of the table, the severity, the occurrence, and the detectability, and then RPN. So the RPN is just the product of these 3 numbers. So it's a number from 1 to 1,000. And then this number by itself, I guess it's good, like as a relative measure. As you could tell, like a 900 is a bit more intimidating than a 112. But more importantly, we should be looking at the event rate, so affecting how many patients per year. So this is worked out from the initial throughput and then how many patients are exposed to that step, and then also the occurrence and detectability. And through all that, we can find that, say, the mix-up of immobilization equipment actually affects 8 patients per year. And from this, we can actually rank risks in our department a bit more effectively. So you can look at things like the delivery error not being plan specific. And that was initially 20 patients per year was affected by this. And we can have a look at that and say, you know what, that's a bit too high. And that's when we can look into mitigating these risks. So I guess, using the mix-up of immobilization equipment as an example, we can just expand the details with a little arrow here. The cause of this is typically, yeah, either repetition or a lack of information. So your setup positioning photos might just be not great. But moving across to the prevention, so as we mentioned, the cause, but the initial prevention is just printed labels for patient-specific equipment. But then we can add additional preventions. For example, if you're adding an RFID electric interlock, we can just, I guess, edit this one for an example. We can name our prevention. We can give it the initial cost. These are random numbers, by the way, and I don't know that for sure. We can just put in a fixed cost, what it costs to purchase the software, and then a recurrent cost, things like how much does it cost every year to use the software, or is there software maintenance and things like that you have to do. And then also the probability of your system missing an error when it occurs. So yeah, preventions are more, I guess, mitigating the cause before, just preventing it from actually occurring. Whereas your barriers, so for example, in our delivery error, we can go across the barriers and we can add things like in vivo dosimetry. So if you're doing a lot of fractions, you pick up any errors in the first fraction rather than getting through all 20 of them or however many fractions you're doing and picking it up at the end. So this is detecting these errors after they've occurred, but before it significantly impacts the patient. So similar as the preventions, we can come in, we can add our barrier, a fixed cost, recurrent costs, the chance it's going to miss it. We can also set it to being an active solution. So this is if we've already implemented this in our department, or if we're thinking about it, or we're just, I guess it's just not on our radar for the time being. So once we've done that, oops, sorry. So once we've put that in and we've got it as a potential, a potential barrier, we can see the effects of adding that barrier. So initially, our detectability was a 9. It's now dropped down to a 7. And it's showing that as we multiply all these numbers through, that we're going to have an impact, or we're going to help, say, 16 patients per year. This also, from the little colors on the left, makes this go from an unacceptable risk to a acceptable risk. This is seen in, I guess, the cost-benefit view. So if we've got a couple of our preventions or barriers set up here, we can see each one, whether they're active or potentially going to be implemented, and we can actually see the benefit on how many patients per year. From this and in conjunction with looking at the costs, we can make a better decision whether it's worth implementing certain things within our department, whether this be purchasing the RFID interlock or getting something cheaper like an in vivo dosimetry system. And that's something that your team would discuss further and be able to make an educated decision upon what safety measures to introduce. Jumping across to the FTA, or the fault tree analysis. So this is, I guess, almost doing the FMEA in reverse. So now we're just starting off with focusing on, the worst case scenarios, what adverse effects can happen to a patient. So on the left, we're looking at things like, the wrong dose distribution, wrong irradiated volume, wrong patient, and I guess so forth. So we start off from that, I guess, what actually happens, and work our way back to the actual initial cause. So it's a bit overwhelming and all in that one table, but maybe if you look at dose distribution, on the right would be the effect of the dose distribution, and we're kind of making the tree, which is probably better represented in the diagram. So at the top, we've got wrong distribution. And then as we work down, each branch is the barrier or things we're doing to mitigate. So things like comparing the setup photos, the RFID interlock, and even back to just printed labels, our initial mitigation efforts. So all of this, I guess, just gives you a better idea of what's happening in department and what we're doing to prevent risks. Um, and then just scrolling along, realize I'm probably jumping through this a bit quick, but we're also the software generates a report for you. So this is a good thing. You chuck your logo up there if you like, a bit of information about your institution, and then it creates a really nice report because it's got each little subsection set out, so you can just put in all your data, all your findings, all your results, and your conclusions, and it'll generate a report based off the data you've input. So this way you've got really good traceability. So if you're implementing, say, a new treatment technique, you can show that you've done all the back end work. You've got evidence to justify the decisions that were made in your department. We've also got version management. So as your risk analysis, as you start off, but then you evolve it, you continuously improve it. Eventually, you'll get to a couple more versions in, and this will be reflected in the report as well. Also, in the settings, it's worth noticing the tolerances. So before we saw how it went from a red to a green, this is based off this chart here. So this is the event rate and severity. And we can come in here and you can just change it depending on what you think is an acceptable risk or not acceptable within your department. But you just go in there, left click, and left click to change it. I believe that's kind of it. I guess the software in a nutshell. Might be a bit quick of an overview, but I guess it's probably a good introduction. It's also, worth mentioning that IBA do offer a wide range of training for this. As I guess risk management is a very distinct thing that maybe not everyone's used to, or maybe they only just do it very rarely. So IBA have the training available so you can compare your department with other departments. You can work with professionals and just work off best practice. And yeah, I think that's pretty much